Hello, am I audible to all?
Yes, ma'am.
Yes, ma'am. Good evening.
Good evening. A very good evening to all of you. Hope you all are hale and hearty. So, today we are going to start with our next lecture, and that is concerned with cheese. Basically, cheese is one of the oldest foods of mankind. It is believed that it has evolved in the crescent between the rivers Tigris and Euphrates in Iraq, and sometimes around 8,000 years ago. And it was originated accidentally. Now, what happened? Because these nomadic tribes, they used to preserve their milk, whatever the animal milk was there, bovine milk or the cattle milk, they used to preserve them in the stomach bags or the skin bags of the animals. So that ways they were preserving their milk for further usage. Now, what happened during the warm climate or when the temperature was high? So fermentation in milk occurred, and moreover, with fermentation, because these skin bags they used to carry on the backs of the animals. So because of the swaying of the animals, whatever the curd was formed, it broke apart. So it broke in between, and it lead to the separation of the whey and the curd mat. So whatever the whey was produced, they were used by these peoples as a drink during their long journeys. And the curd, they used to preserve it by adding salt to it. And it was a very good source of protein for them. And when, because they were traveling, so they were not having that non-veg meat or meat products with them, so that was a very easy source of nutrition for them during their journeys. So that ways it was discovered by these nomadic tribes. Now, what is the definition? Basically, cheese is derived from a English word that is cheese. So, and this cease word is further derived from a Latin word that is caseus. So, basically, this caseus means that it is a perfect thing. So, if we want to define cheese, it may be defined as the curd of the milk which is separated from whey, and it is further pressed to make it a solid part. So that is known as cheese. That curd which has been pressed, and whatever that is obtained, that solid thing is obtained, that is known as cheese. But this definition is not complete in itself, because if we see the technological aspect, that is not covered in this definition. So the actual definition is, it is the curd or substance which is formed by the coagulation of milk of certain mammals. It is not only buffalo or cow milk, sheep milk, goat milk, they are also included. And these type of milks, they are coagulated by adding rennet or some similar enzymes like chymosin is there, pepsin is there, in the presence of lactic acid, which may be produced by added or adventitious microorganisms. Adventitious microorganisms means that the microorganisms which are unintentionally introduced into the manufacturing process, that means they occur naturally. So these are known as adventitious microorganisms. So whatever the milk, when it is coagulated, and from after coagulation, from that moisture is removed, by cutting, warming, and pressing, and then they are further molded and may be ripened or unripened by keeping them at ambient conditions or some special kind of temperature and humidity conditions. So the product obtained is known as cheese. So basically, the cheese, it is obtained either by coagulating milk, skim milk, or partially skimmed milk. It may be whey, cream, or butter, or the combination of these things through adding rennet to it or other coagulating agents. As I have told you, there are certain more enzymes like chymosin is there, pepsin is there, and then the whey is removed from it. It is not completely removed, it may be partially removed depending upon the kind of the cheese to be made. Or it may be said that the whatever the processing techniques we are using, in that one condition should be fulfilled, that whey protein casein ratio does not should not exceed that of milk, and whatever the end product is formed, it should be such that it should have similar physical, chemical, and organoleptic characteristics as may be obtained when we are following the process that is defined in step A or point A. So, according to FSSAI, it means the ripened or unripened, soft or semi hard, hard, and extra hard product which may be coated with food grade waxes or polyfilm, and in which the whey protein or casein ratio does not exceed that of milk. That is known as cheese. So, whatever the cheese is there, it should contain the starter cultures which are having harmless lactic acid bacteria or the flavor producing bacteria, or it may have the cultures of other bacteria also, but they should be safe for human consumption, and it may contain suitable enzymes and sodium chloride. So the cheese may be in the form of blocks or slices, or it may be in the cut pieces, shredded, or in the form of grated cheese. So this FSSAI, it has also defined on the basis of the ripening. So basically, ripened cheese is that kind of cheese which is not suitable for consumption immediately after its manufacturing, but after its manufacturing, it has to be kept at certain special temperature and humidity conditions, so that the biochemical or the desired physical changes may occur in the cheese, and which render it fit for the consumption. For example, like mold ripened cheese. Mold ripened cheese is basically in which the mold development occurs either externally or internally. In that is like Roquefort cheese is there, that blue cheese, blue veined cheese, that is known as Camembert. Then is unripened cheese. It is the fresh cheese which can be consumed immediately after its manufacturing. Then comes the classification of cheese. It is very important. Cheese is basically classified into four categories. First one is very hard, and this classification is based on the amount of the moisture that is present in the final product. For example, first one is very hard. So, very hard means that the moisture content is less than 35%. And the examples are like Parmesan cheese or Romano cheese. Actually, they are not going to ask you the classification. They can ask what is the moisture content in this very hard type of cheese or semi hard type of cheese, and sometimes They give the name of the cheese and they ask you whether it belongs to very hard, hard, semi hard, or soft category. So this is the way how the questions are being asked in the exam. Then comes the hard cheese. Hard cheese are the cheese whose moisture content is between 36 to 40%. So, if they are ripened by bacteria without ice, then it is known as cheddar cheese. And if it is ripened by bacteria with ice, then it is known as Swiss cheese. Then is the semi-hard variety. Semi-hard variety, in that the moisture content ranges from 40 to 47%. So basically, this is ripened. If it is ripened by bacteria, then it is brick type. Ripened by bacteria and surface microorganisms also, then it is known as Limburger. Then is ripened principally by mold. Then it is known as, if external ripening is there by blue mold, then it is known as Camberberti. And if internal ripening is there, then it is known as blue or Roquefort or Gorgonzola. So these are the types of the cheese with external ripening and internal ripening. Then comes the soft cheese, whose moisture content is greater than 47%. Then unripe, it is cottage cheese. And if it is ripened, then it is Neufchâtel cheese. So these are the legal standards. Then again, they are important because they may ask what is the moisture content or the fat percentage in these types of milk. For example, in case of mozzarella cheese, because this is very popular, so moisture content is 60%, so this is soft kind of cheese, and the fat percentage is 35%. If we say pizza cheese, then it is 54% moisture and the fat content is 35%. So depending upon the type of the cheese, moisture content and milk fat, they varies. So this we will discuss later on. This is like just you have to go through it. For example, like curd coagulated primarily by acid, then it is cottage or Newcastle cheese. Then is curd particles matted together, then cheddar or Cheshire cheese. So different types of cheese according to their processing. So first we should know what kind of processing is there and what are the steps and how they are differentiated from each other. So first we will discuss that. Then is the cheese manufacturing process. So basically, if we see any cheese manufacturing process, it may be cheddar or it may be blue cheese or Roquefort cheese or whatever. So these are the main processing steps. First thing, okay, these are made from the milk. It may be derivatives of milk or it may be from any mammal. Then second thing is soaring is done. Then clotting by rennet or some same kind of enzymes. Then is cutting and breaking up of the coagulum and releasing it. Then is the consolidation or matting of the curd. Thereafter ripening, maturing. Yeah. So these are the main steps which are usually carried out in preparing each and every type of the cheese. So there are certain factors which influence the final cheese quality. So these factors are like what kind of milk you have used. Then is what is the degree of soaring. That means what is the acidity, how much acidity has been evolved because of the soaring organisms which are added, and what kind of organisms are being added. Then is at what temperature rennet is being added and whether it has been cooked thereafter or not. I may use cooked or it may be scalding. So, what does it mean? Scalding, basically, it means that the curd which is produced, its temperature is raised to 35 to 38 degrees Celsius over 30 to 60 minutes. It takes this much time to heat it. Because if we increase the temperature very quickly, then the whatever the curd is formed, it will form a rind on its surface. Rind is like peel, that chilka, it will form a rind. And that ways, the way it will not be removed from the curd, it will be held inside the curd. So this is what is meant by scalding. Then is the milling and the salting, and then pressure is applied to the green cheese. Now again, one new word, what do you mean by green cheese? So first thing which strike to our mind is it should be green in color, that is green cheese. But yes, it may be green in color, but actual meaning of green cheese is it is unmatured cheese. That means it is fresh cheese which is not thoroughly dried, and nor it is aged. That is known as green cheese. Then is time, temperature, and relative humidity of ripening. And then is the special treatments, like it may be immersed in a brine solution, that is salt solution, or it may be given a surface treatment also, so that it may produce a certain type of coat on its surface. So these are the factors which are responsible for the final quality or the final type of the cheese. So basically, if we see every cheese manufacturing process, basically what it involves, it is the syneresis of the rennet milk. What do you mean by this syneresis term? It means weeping. Weeping means then tears roll out of our eyes. So same way, when curd weeps, then whey comes out of it. So that is known as syneresis. So it is the syneresis of the rennet milk coagulum. The expulsion of moisture, it is affected by, now this is very important line, acid development. Acid development means the pH which is initially near neutral, that is 6.6, 6.7 or 6.8, it is brought down to 5 because of the lactic acid bacteria. And the main bacteria which are being used are Lactococcus lactis and Lactococcus cremoris. Then the second thing is the warmth. Warmth means the temperature is raised to about 38 degrees Celsius. And then is the repeated cutting and the stirring. So when these processes are carried out, the curd will release whey. That means weeping of curd will take place. So how much curd is extracted from the curd, that will further decide the moisture content of the cheese and the type of the cheese, whether it is very hard, semi soft, or soft. Okay, so these are the factors. Now broadly, what we can do is, okay, when we are preparing cheese, so we can divide it into two phases. Like first is the manufacturing phase and second one is the ripening phase. So if I say manufacturing phase, that means whatever the bench operations which are carried out during the first 24 hours, because it is just 24 hours, they may linger on for certain more time also, but generally speaking, whatever the unit operations which are carried out, or the bench operations which are carried out in the first 24 hours, they are known as, they come under manufacturing phase. And other operations, for example dehydration is there, for example salting is there, or ripening is there, so these come under the phase that is known as ripening phase. Okay, so basically the main processes are five, which have a impact on the moisture content of the cheese. And these are, first one is acidification, then is the coagulation, then is the dehydration, and dehydration, after that shaping and salting. So these are the main processes which affect the amount of the moisture that is retained in the cheese, and that is going to determine the type of the cheese which is to be produced. So this is the cheese manufacturing process, this flow chart. Like first we take the milk, and after taking the milk, it is not like we have taken the milk and now initially what we will do, we will add starter culture and then all that whatever is to be added. No, first the proper kind of milk is to be taken, that we are going to discuss. Then the milk is treated. Thereafter standardization of the milk is done. Then whatever the milk is obtained, that is known as cheese milk. And after we get the cheese milk, then the starter culture or the color or the calcium chloride, that is an optional thing, and the coagulating agent are added to it. Thereafter we get the coagulum, and coagulum, it is cut, it is stirred, it is heated, acidification is done, and then the separation of the curd from the whey takes place. Then if then what we get curd. Now whey is removed, so that curd, it may be salted, it may be cheddared, it may be stretched, then acidification may be carried out, and after all these things, then salting, then molding, and then pressing, then we may get fresh cheese or the green cheese, then salting, and then ripening, and what we will get is the mature cheese that can be marketed further. Now, first thing is the selection of the milk. Now, selection of the milk, basically the kind of milk or the quality of the milk, that has a very strong influence on the quality of the cheese, what is produced from it. Whatever the raw material, kind of raw material you are going to use, and that is certainly going to affect the final quality of your final product. So basically, uh, the composition of the milk, the fat content of the milk, the protein, the pH, the calcium, these are the major factors which affect the quality of the cheese. And what are the factors that affect these things, like the composition of the milk? That is from the species from which the milk is derived, then breed, then there may be certain individual variations also, nutritional status of the animal, health of the animal, and then is the stage of the lactation of milk producing animals. Now, again, this is very important. Please pay attention. So, the animal which is having mastitis. Now, what is mastitis? Mastitis means the normal pH of the milk is 6.7 or 6.8, but the animal having mastitis, he or no, the animal, they will give milk which is having a pH of basic nature. Basic means that the pH will be above 7, so it will be having alkaline nature. So this mastitis, it causes certain changes in the milk, because it changes the composition of the milk. Now, how it changes the composition of the milk? See, that means uh, basically the firmness of the coagulum after adding rennet, it is enhanced, it is basically increased by acidity, by calcium, and by the casein content. But if it is alkaline in nature, alkaline means, that means the milk is produced from the animal having mastitis, so it will be reduced, it will be having low casein, it will be having high sodium, it will be having high albumin, high globulin, but it will be having low calcium and low casein content. So that ways it will affect the firmness of the coagulum that is obtained by adding rennet to it. So that ways it plays a very important role. Now, one thing more, milk from cows which are in very early or late stage of lactation, and those suffering from mastitis, they should be excluded. And what is the reason? That I have explained already to you. That means these acidity, the calcium level and the casein content, these are reduced as the pH increases. That means it shifts toward basic medium rather than acidic medium. Now, next thing, what kind of fatty acid composition is there? Now, basically, the caseins from all type of triogenic milk. Now, this is again one new term. Triogenic, it means the milk which have the capacity to be converted into cheese. They are known as triogenic milk. So, casein part, milk, basically, the main protein is casein. So, whatever the casein is there, that is almost same, but there is difference in the fatty acid composition of the milk. Basically, what happened during ripening, some fatty acids are released. So, if medium chain fatty acids like C6 or C10, C6, C7, C8, C9, C10. So these kind of fatty acids are liberated during ripening. Then the kind of cheese, it will be having peppery or the biting flavor as compared to very short or longer chain fatty acids. So basically, it is assumed that whatever the flavor is there in cheese, it is because of the lipolysis of the fat. So what the mammals which have higher proportion of medium chain fatty acids, they will be having peppery flavor. That is basically seen in Roquefort cheese, which is always made from sheep milk because it contains higher proportion of medium chain fatty acids. Then comes the inhibitory substance in milk. Most of us haven't heard about this thing, inhibitory substances in milk, because we have seen in pulses, we have seen in these nuts also, but milk we have never heard and very rarely heard. So again, this is a new thing. So basically, uh, these cheese, they depend upon the growth of lactococci. Lactococci is the bacteria which increases the acidity in the cheese. So basically, this milk, they contain one inhibitory substance that is known as lectanin. So basically, this lectanin, it is bacteriostatic substance. Bacteriostatic means it stops the growth of the bacteria. Now, in cheese making, we require the growth of the bacteria, that is lactococci, but lectinin, it is going to stop the growth of the bacteria, or it will slow the growth of the bacteria. So these are bacteriostatic, and these their composition is not so much known, but they are almost similar to the proteins. You may say they are a kind of proteins. So this lectinin, it is of two types, that is L1 and L2. So basically, L1, it is present in colostrum, and L2, it is present in mid lactation milk. So these L1 and L2, they can be inactivated by heating the milk to 70 degrees Celsius for 20 minutes. Or sometimes what may happen, this is one inhibitory substance. Suppose the animal is having mastitis. So if the animal is having mastitis, he or she will be given that penicillin or some other kind of antibiotic, and these antibiotic will be released in the milk. And if we are using that kind of milk in preparation of cheese, then what will happen? Because penicillin or whatever it is there, these are antibiotics. These will stop the growth of the bacteria. Therefore, they will inhibit the growth of our starter culture. So that may adversely affect the quality of the cheese. Then comes the standardization of milk. Now, what is this standardization of the milk? So, basically, in standardization, we have to standardize the casein and the fat ratio. So, what is said that casein to fat ratio should be 0.7 to get a good quality cheese. So, basically, so now, in each and every kind of milk, this ratio will not be there. So we have to modify it. Either we may remove some kind of fat by creaming method or by centrifugation. We may add skim milk to it, because if we are adding skim milk, then automatically we are decreasing the amount of fat and increasing the volume. Then we may add the cream if fat is not there. We may add milk powder or evaporated milk or ultra filtration retentate. So they may be added to it. So basically, these kind of additions, they help in increasing the total solid content of the milk, and that ways they help in increasing the yield of the cheese also. Because what will happen, if the ratio of casein to fat is high, then whatever the curd is obtained, it will be leathery. So leathery means stretchable kind of. And the final cheese which we will get, it will not be having that mellow character or velvetiness in it. So that ways it will affect the final quality of the cheese. So we have to standardize the milk by all these four methods. Then is the heat treatment of the milk. Now, heat treatment is required. We may go for pasteurization milk, but one thing is there. If you see in countries like New Zealand and all, which are like the main parts of the world where the cheese is being produced, Swiss countries. So basically, what happens? They use raw milk, and they use clean milk practices, so that the milk is not cross contaminated with other kind of bacteria. But in India, these conditions are not feasible because the people are not so aware. Moreover, the environmental conditions are not so suitable, so pasteurized milk is basically used. But one thing is there, whatever the cheese which is produced from pasteurized milk, it will not be having the native flavor. It will not be having that kind of flavor which is obtained from the cheese made from raw milk. It will ripen slowly. Now, why these changes occur? What pasteurization do in milk? Basically, first thing, it inactivates the natural enzymes which are present in the milk. Then it kills the natural microflora which are present in the milk, that is known as adventitious microorganisms. It causes denaturation of the whey proteins, and it also causes some change in the interaction of these with micellar kappa caseins, and even it shifts the salt equilibria and destruction of certain vitamins. So these things are quite associated. They may be associated with the less intense flavor and the slow ripening of the cheese which is prepared from pasteurized milk. Then next step is the ripening of milk. Ripening of milk means acidification. Now, acidification means development of acidity in the milk, and this process in which the acidity of the milk is increased for processing it into cheese. This process is known as ripening, and for that we use various types of starter cultures. So basically, these starter cultures, the required acidity is 0.01%. That is required. So when this is reached, then the rennet is added to it so that it sets in the form of a curd. And thereafter, for acidity, what we do is we use lactic acid, but it may be by using that acids or like acidogens. Basically they can be added directly to acidify the curd for some varieties such as mozzarella cheese or uf feta cheese or the cottage cheese. So the acids which are generally used or acidogens are used, that is gluconic acid, lactone, so that may be used for it. So that whatever the culture we are using, that may be homo fermentative or it may be hetero fermentative. Now what is this homo and hetero fermentative? Homo means one, same, and hetero means matlab variety is there. So homo means that that kind of culture, it will produce only lactic acid. That is, the principal metabolite is lactic acid, and it will not produce carbon dioxide or other flavor compounds. So that is known as homo fermentative kind of culture. And if it is heterofermentative, that means lactic acid is produced, that is the principal end product, but with that some significant amount of other metabolites like carbon dioxide is there, short chain fatty acids that is responsible for the flavor. Then is acetaldehyde, that is basically for yogurt kind of flavor, diacetyl, ethyl alcohol. These kinds of other metabolites may also be produced. So that is basically homo fermentative or hetero fermentative. So for like cheese varieties in which cooking is not more than 40 degrees Celsius. So a starter culture consisting of Lactococcus lactis and Lactococcus cremoris. This is generally used. And if we want to cook it to certain higher temperature, then we may use Streptococcus thermophilus or like lactobacillus or lactobacillus bulgaricus or lactobacillus helveticus or lactobacillus casei. So these may be used. So that depends कि the cooking is to be done up to 40 degrees Celsius or it is to be done up to more than 40 degrees Celsius. And these kind of bacteria which can survive only up to a temperature of like 39 or 40, these are known as mesophilic bacteria, and which can survive a temperature of more than 40 degrees Celsius, that is known as thermophilic bacteria. This you must have covered in your microbiology class. And one thing more I want to add, that these thermophilic bacteria, these are a blend of cocci and rods. So they have certain characteristics like the cocci, they prefer higher temperature, that is around 46 degrees Celsius. But rods, they prefer lower temperature, that is 39 degrees Celsius. Then second thing, the rods, they are more acid tolerant than the cocci. So this I want to add. Might be who's the teacher who is teaching you microbiology, he must have explained, but I felt this is a bit important, so that's why I have added this too. Now three types of cultures. I have told you mesophilic, thermophilic, and adjunct. So mesophilic, that is basically temperature is 30 to 35 degrees Celsius, but their growth is inhibited at a temperature more than 39 9 degrees Celsius. Then comes the thermophilic. They grow at a temperature above 40 degrees Celsius. So they are thermophilic. And then is the adjunct cultures. Basically, these are added for some special type of taste or texture. And there are certain enzymes which are produced by bacteria, and these enzymes are basically responsible for that particular taste and texture. So these are this slide shows the microorganisms which are involved in making various kinds of cheese. For example, these Italian cheese, Swiss cheese, Emmental cheese, yogurt, Lactobacillus bulgaricus, and Lactobacillus lactis. So they cause acid flavor. Then is Propionibacterium shermani, that is flavor and eye formation, that is in Swiss cheese family. So this is basically it gives you the kind of the culture which we use and the type of the product that is produced. For example, in case of cottage cheese and starter culture, Leuconostoc citrovorum and Leuconostoc dextranicum. So these are the bacteria or the species which are being used. Then comes the coagulation. What is coagulation? Coagulation, we mean by the term coagulation is it is the formation of the gel which is obtained by destabilizing the casein micelles, so causing them to aggregate and form a network. So because of the formation of the network, they help in partially immobilizing the water, and they trap the fat globules in the newly formed matrix. So basically this process is known as coagulation. So the coagulation, it may be achieved by enzymes like chymosin or rennet is there, pepsin is there. It may be achieved by acid treatment. It may be achieved by heat and acid treatment. So three types can be employed. One is enzyme, one is acid treatment, another one is acid plus heat treatment. Now what happens? If we add enzymes, then it is limited proteolysis by selecting limited proteinases. Then acidification is done up to a pH of 4.6. And if we are using acidification plus heat for coagulation, then the pH is dropped to around 5.2, and then heating is done up to a temperature of 90 degree Celsius. Basically, in normal milk, what happens, why it does not coagulate or why the casein does not stick to each other? This is again important point, that kappa casein on the surface of the micelles, this does not allow the coagulation of the casein, and a negative charge on these micelles, it repel each other. So that is why they do not coagulate or they do not stick to each other. Now, what is rennet? Rennet is basically an enzyme, and it can be obtained from four sources. First one is the stomach lining of the calf. So basically, why from the calf? Because this enzyme, it helps in the digestion of their mother's milk. So that is why it can be obtained from that. Then is from plants. Plants may mainly thistle plant. Then is the microbes in the fungus and yeast can be used. Then is the genetically engineered rennet, and it is imitation of the rennet. It is not actual rennet. It is like obtained. It is processed in the factory. It is produced in the factory. Artificial rennet. So renin is quite a very powerful clotting enzyme, and one part of pure renin is able to clot more than 5 million parts of milk. Now you can see how powerful it is. and the optimum pH for renin action on milk is 5.4. This is the important point. What is the optimum pH for renin action? It is 5.4. However, it can function at neutral, almost neutral. It is not neutral, it is low acid. So it is 6.2 to 6.4. Again, it is a very powerful clotting agent, but optimum pH is 5.4. Now, how rennet works? Basically, what happens, calcium caseinate is present in the milk because calcium ions, they combine with the casein molecules to form calcium caseinate. Now, what happens when rennet is added to it? This calcium caseinate, it gets converted to para casein. Now, this para casein, it then combines with the casein, gets converted into para casein. Para casein, it combines with the calcium ions and it leads to the formation of an insoluble curd. So basically, what happens, whatever the curd that is obtained, it is quite elastic in nature. But when it is heated, so then it will shrink and it will release the whey, whatever is retained inside it. So, sometimes what is done is calcium chloride may be added. If you remember, I have shown you a flow chart in which I have mentioned that calcium chloride is optional. So, why calcium chloride is to be added? So that calcium is available to the paracasein to form an insoluble curd. So for that purpose, it may be added in very small amount, that is 0.02%, so that the renin can show its action and we can get a perfect curd out of the milk. Thereafter, it is post coagulation processing operations. So, when the coagulum is firm, then it is cut by mechanical knives like this. They are cut. So, they are cut in horizontal action also as well as in the vertical action. This is the way it looks like. This is the curd which has been cut with the help of the knives. So, that is done, and the cutting, it takes around 20 to 50 minutes. So this depends upon basically the concentration of the rennet. Then it depends upon, because if more rennet is used, then it will, the curd formation will be fast. If less amount of rennet is used, then the coagulation will be slow. Then second thing, whether you have added calcium chloride, because calcium chloride, it will accelerate the clotting. Then is the coagulation temperature. What temperature is there? It occurs fast at a higher temperature. Then is the pH, because as the pH increases, the activity of chymosin decreases. So that ways pH has to be low to show its action. So it depends upon this. It will take 20 to 50 minutes. Then is the seasonal changes. Seasonal changes, because if we take late lactation milk, then it will be having high pH. If high pH, then again the problem will be there in the formation of coagulum. Then is what type of water we are using for the dilution of the rennet to get a solution, rennet solution. Because if the water, it is having chlorine, a high level of chlorine, and it is a hard water, then again it will be it will be increasing the coagulation time. So again it is a problem. So this is how cutting is done. Thereafter, the term is cooking. Now, cooking, what does it do? Cooking, it basically helps in shrinking of the matrix, and that's way it helps in draining the whey from it. So basically, lactic acid production, if it increases, then the pH will decline, and pH declines, then this acidity will help in the shrinking of the particles more. It will increase the shrinking of the particles. So that means it depends upon the kind of the bacteria which are used, and moreover for the acidification, and moreover it depends upon the acidity, that is the pH. Now this is again one important point, because whatever the way is there, because when whey is expelled out, uh, around 50% of the lactose and other salts, so they will also be they will go with the whey. So whatever is the amount of these substance in cheese, it will depend upon the amount of moisture in the curd. Because if we remove all the whey from the curd, then the amount of lactose and salts will be drained with whey. So it depends upon how much amount of lactose and salts are present. It depends upon the moisture content in the whey. Then is the calcium phosphate, which is associated with casein. It solubilize as the pH falls. Then again, one thing more important is the curds which are having high acidic content. For example, in blue vein cheese, they lose more calcium than low acid curds. The reason being, because as the pH decreases, this calcium phosphate, which is associated with casein, it will be solubilized in the whey. So if it is solubilized in the whey is to be drained off. So that means this calcium will also be drained off. So that is why the curds which are having high acid content, that means they are having low pH. They lose more calcium than low acid curds, because in high acid curds, calcium phosphate, it will be solubilized. That is the reason. Then how the curd treatment is given, so it depends upon the kind of the cheese. For example, if soft high moisture cheese is to be made, then the curd is to be removed from the vat quickly and the whey is drained. From some varieties of cheese, the curd is cut and stirred in the whey while it is being heated. Cheddar type of cheese, the curd is heated in the whey and allowed to form continuous mass, which is then cut and milled into small pieces before further processing. So it depends upon what kind of cheese is to be made, and then the treatment of the curd is decided. Then again, how the whey is drained, that is also going to depend upon the type of the cheese. Because cream cheese, then what we will do, we will place the curd on the cloths, so that ways the whey will drain out. Sometimes the curd, it is placed in hoops on mats, and then they are allowed then the whey is allowed to be drained, so they are used in the manufacture of brick cheese. Then is, in case of cheddar cheese, curd is allowed to sink in the vat, and then the curd which is on the top surface, then it is removed. Then in Swiss cheese, curd is separated by placing a cloth under the curd and lifting it out of the vat or the kettle. The curd is inside the kettle. We put the cloth inside the kettle from underneath, and then we take the cloth out. So that ways the whey will be separated. Sometimes what we do is we put them on a draining belt. So what will happen? Draining belt, they will separate the curd from the whey, and moreover they will cool the curd and the whey. So one term is generally used, that is known as cheddaring. Now what is this cheddaring? Basically what happens when this curd mat, because liquid has been drained off and whatever the solid is produced, that is known as curd mat. And when this curd mat, after draining off whey, it is placed one on the above, like means they are in uh, piles, like this, these persons are doing. So they are piled on the top of each other and they are turned in regular intervals of time. Then this process is known as cheddaring. And the last one is the pressing. uh, Not the last, but salting is again there, then pressing is there. So basically pressure should be applied such that it should be less initially, and then the pressure should be increased. The reason being, because if we apply the pressure, a very high pressure in the beginning only, then what will happen, pockets will be formed and the moisture will be locked inside these pockets. So that ways it will affect the texture of the cheese. So another thing is the temperature of the curd before pressing. It should be such that the temperature should be such that it should be below the liquid fat temperature. That means because if the fat is in liquid state, then it will be removed with the whey. Or it may happen that whatever the pockets are formed, it may get accumulated in these pockets and it will lead to a greasy texture. So it should be 23.9 degrees Celsius in summer and 26 degrees centigrade in winter. Then is the pressure, whatever is to be applied to the cheese, it should be per unit area of the cheese, not per cheese. That is a very important point. It should be per unit area, because as the size will vary, same way the pressure will also vary. So this is a full picture which shows raw milk is there, then pasteurization or traditional cheese making directly. We heat it to a certain temperature like 30 or 35 degrees Celsius. Then we add the starter culture side by side, the rennet that leads to the formation of curd. Then is the cutting. After cutting, stirring and cooking. After stirring and cooking, then it goes to the draining of the whey. After draining, then milling, then salting, and then is molding, and then is pressing, and then ripening, and then it is marketed. Now comes the treatment of the rind. Basically what kind of rind is required, because in like different kinds of cheese have different rind characteristics. For example, cheddar cheese is there or Swiss cheese is there. So in that, smooth or uniform surface is required. So in that case, the curd is pressed while it is still warm and curing the cheese under conditions that allow the moisture to evaporate from the surface. Then is, in case of Swiss cheese, activity of the organisms on the surface, they periodically clean the rind. So that ways the activity of the microorganisms can be checked on the surface. Then one more treatment, like for cheddar cheese, the cheese is coated with paraffin wax, or it is molded in a cool room with low humidity, which will inhibit the growth of the surface microflora. Then is like camembert is there, Roquefort cheese is there, in which the growth of mold is to be there. So that ways they are held in cool or moist environment. And if the growth of yeast and bacteria, it is on brick cheese and Limburger cheese. So uh, in this rind is kept clean by repeated washing with a salt impregnated cloth, for example emmental cheese may, and then is repeated brushing to remove mold growth, Cantal cheese. So there are different kinds of cheese and different type of treatments are there. Some, they apply the coating of olive oil, and in olive oil also they will add some color like brown or black. For example, parmesan cheese is there and romano cheese is there. Sometimes smoking of the cheese also is carried out, so that there is a coat of fatty layer, and it will be having a preservative effect because of the phenolic compounds contributed by the smoke. Then feta or other cheese are there. They may be packed in cask or drums, which are filled with brine or the salted whey. And last one is the salting. Basically, salt, it may be rubbed on the surface. It may be immersed in a salted whey or brine solution. So basically, salt have certain functions, like it helps in extruding out the whey from the curd. It uh, checks the growth of unwanted microorganisms. It helps in regulating the growth of desired organisms, for example lactic acid bacteria. It causes certain physical and chemical changes in the cheese. It modifies the taste, and it also controls the acidity of the cheese. Then is the maturation or ripening. Ripening is basically breakdown of proteins, lipids, carbohydrates, etc., and the release of flavor. So ripening may be like from 0 day to 5 years. It may be there, as it is the same thing like the wine which is older. It will be considered as good quality. Same way the cheese more aged, it will be having better quality. So ripening, it may be interior or the surface ripening. So this is how ripening of cheese is carried out. Then comes the packaging. Temperature or time, it should be around 10 degrees Celsius until or unless it gets matured. And then is this slide shows the application of the cheese, like consumer and what are the ingredients which can be prepared from this. And this is the functional requirement, like it should having the property of shreddability, that is the ability to be shred into thin strips. Then is sliceability, ability to be cut cleanly into thin slices without crumbling. It is required in Swiss type cheese. The quality required in cheddar or cream cheese is the ability to melt and flow. Cream cheese, it should have the ability of spreadability. Crumbliness, it should be in Cheshire and feta. Then is the stretchability, that should be in the mozzarella cheese. So these are certain questions which I found that they might be useful to you. Like, which of the following leads to the formation of soft cheese? Like removal of small portion of whey using more amount of milk, removal of larger proportion of whey using less amount of milk. So the answer is removal of small proportion of whey. Because why removal of small proportion of whey? Soft cheese, it is having more moisture content, so more moisture content means less amount of whey is to be removed. Because as we go on increasing the removal of the whey, the cheese will be more hard. So that ways, first is the answer. Then is the large holes in the cheese are due to oxygen, carbon dioxide, sulfur dioxide, or lead dioxide. It is carbon dioxide. I have told you na homofermentative and heterofermentative cultures, because these are due to the production of carbon dioxide. And one more slide in which I have told you Propionibacterium shermani. So basically, that leads to the evolution of the carbon dioxide, which is responsible for those eyes or large holes in the cheese. Then, which of the following is a rennet free cheese? Rennet free means no rennet is being added. So Gouda, cheddar, and Parmesan, these all have added rennet. But Kraft Philadelphia cream cheese, it it does not consist rennet. So that is why it is a vegetarian cheese. Then is the fermentation of milk to form cheese is done by dash bacterium species. So that is lactobacillus, because neither we are using Saccharomyces, Aspergillus, Penicillium. They are not being used. And one more thing, Saccharomyces is yeast, Aspergillus, Penicillium. These all are like fungus and yeast. So basically, what we are using is Lactobacillus species. So this was all about cheese. Now questions from your side. Yes? Any questions?
Hello, ma'am.
Hmm.
What is colostrum?
Colostrum is beta, the first initial milk which is produced by the mother, that is known as colostrum, and it is quite rich in immunoglobulins that is responsible for the immunity, because the newborn child, they don't have innate immunity that is inside the body. They don't have any kind of immunity. So for that purpose, uh, that colostrum is to be feeded to the newborn babies. It may be in case of human beings or it may be in case of animals.
Okay.
Yeah. Anything else? Is it clear to you all? Whatever
Ma'am,
I have to. Huh?
is there any different time period for aging of cheese, or like for different type of cheese, there will be different time period of aging, or it will be same for all the
No,
cheese?
no, no. It will be different for different types of cheese, because there are certain cheese which are eaten unripe, and there are certain types of cheese which can be which cannot be consumed immediately after their formation. So that depends upon the type of the cheese and what kind of the rind characteristics we require, what kind of flavor. So it depends on that.
Okay, ma'am. Thank you.
Okay. Anything else? Should we start with the second lecture then?
Yes, ma'am.
Yes, ma'am.
And one more thing, students, I have given you that objective food science book now. I think I have messaged in the group.
Yes, ma'am.
So, whatever the topic we are covering, like on Friday, so you can open that book and you can do MCQs from that, so that it is easy for you people to remember whatever is taught in the class. So, are you following this practice or not? Yeah, should I give you additional MCQs? Yeah, from that book I should copy and then give it to you, and then only you are going to do. Hmm? Are you people doing or not?
Yes, ma'am. We are
Have
practicing.
Yeah, have you accessed that book? No, no one will speak. Huh? Hey, you people are grown up now. You have done your graduation, so you should speak. So this PPT is visible?
Yes, ma'am. It's visible.
Okay. So the next topic is dried milks. Milk powder,
Yes, ma'am.
milk powder you have seen, all of you?
Yes, ma'am.
So today we are
Yes, ma'am.
going to discuss how it is manufactured and what are the different types and how it can be prepared by using different methods and what are the properties which are required in this type of milk. So what is dried milk? Basically, dried means that means moisture has been removed. So that is known as dried milk. So that means the type of milk from which the moisture has been removed, and this may be whole milk, it may be low fat milk, it may be skimmed milk. And one thing that we should be able to use or reconstitute the dry product with water according to the directions which are mentioned on the package. So, the disadvantage which is generally seen in it is that the flavor of the milk powder changes, and that is because when it is opened, it comes in contact with the oxygen, that is the outer environment, that may lead to flavor changes in it, and sometimes during its preparation also cooked flavor may be there in the milk powder. So it's disadvantage, but advantage is, okay, it can be kept for longer duration of time. Then second thing is, okay, we can prepare that much amount of milk that is required. No need to prepare, no need to keep like 3 4 liters of milk and then keep it in refrigerator or something like that. Whatever the amount of milk is required, we can reconstitute from the milk powder and we can consume it. So this is its major advantage. Now, these are the standards. This is commonly asked. This is commonly asked. I have seen, like, what is the moisture content in it? It should not be more than 5%. Like in whole milk powder, it should not be more than 4%. If it is partly skimmed milk powder or it is skimmed milk powder, it should not be more than 5%. Then is the milk fat. In whole milk powder, it should not be less than 26%, titrable acidity not more than 18%. Then, second thing which is asked, how this titratable acidity is expressed. How it is expressed? It is expressed as milliliter of zero point 0.1 normal NaOH per 10 gram of solids. That is the percentage of lactic acid. Percentage of lactic acid. Then is insolubility index in all three types of milk powders. It should not be more than 2 milliliter. In partially skimmed milk powder, fat, it should not be less than 1.5% and it should not be more than 26%. And in skimmed milk powder, it should not be more than 1.5%. So these parameters are important according to FSSCI. What is the amount of moisture limit or the fat limit or the titratable acidity? Then is if we are producing milk powder, then what is the main objective behind it? Why it is to be prepared? Basically, the main aim behind the processing of the milk into milk powder is to convert a perishable item into a finished product which can be stored for longer duration of time. That is the main objective or the aim of processing of milk into milk powder. So basically, some drawbacks are there. It's decrease in quality because of the formation of gluey or tallowy flavors. That is because of Maillard reaction and auto oxidation. And then is its nutritive value deteriorates because of the decrease in the availability of an amino acid, that is lysine. Then second thing is, suppose if moisture content increases and the storage temperature is high, then there will be caking. It is because of lactose crystallization. This is again important. Caking in milk powder is because of lactose crystallization and because of the enzymatic action. Then microbial deterioration may be there with increase in moisture content as well as increase in the temperature. Then whatever the powder which is produced, it should be easy to handle. It should not dust too much, and it should not be voluminous also. It should be free flowing, that flow readily from an opening, and it should not stick to the walls of the vessels or the machineries, because they have to be used in coffee machines also, those which are installed in big enterprises. So that ways it should be free flowing and non-sticky in nature. Then again, one more important thing, you have seen in the table insolubility index, it should not be more than 2%. So here this thing is there. After adding water, the powder should not be reconstituted complete, it should be reconstituted completely, there should not be any residue behind it. That means there should not be any undissolved powder particles left, no oil droplets on the top of the solution. So that is there, there should be no lumps. And generally the milk powder, it is dissolved in hot water, but the powder which can be dissolved in cold water also, that is known as instant powder. It is known as instant powder. So one special step is there, that is known as agglomeration, that is carried out to give it this property of instantization, that is dispersion in cold water. Now, mm, suppose whatever the product is there, uh, if it is to be used as beverage milk, then there should be no cooked flavor. If it is to be used in cheese making, then it should have good clotting properties. You have studied in the previous lecture that the increase in temperature, it changes the properties of the milk, and that ways it have a negative impact on the clotting properties. So if the powder is to be used for cheese making, it should have good clotting properties. If it is used to make recombined evaporated milk, it should have good heat stability. So depending upon the requirement, it should fulfill those requirements. Then is these milk powders are then again classified as low heat, medium heat, and high heat. Now, what is the difference? Low heat milk powder is the most soluble milk powder, and high heat milk powder is the least soluble milk powder. So, what we prefer when we have to use it in beverages and all, that is low heat milk powder. Then the product should be free from health hazards, toxic substances, or pathogenic microorganisms. These are the types of the milk powder, like dry whole milk, dry buttermilk, dry whey, dry ice cream mix, dry creams, dry high acid milks. So these are the different types of milk powders which are there in the market. Then comes the nutritional value. Milk powders, they contain all standard amino acids. Amino acids are the building blocks of proteins, and they are high in soluble vitamins and minerals. Then is according to USAID. USAID is United States Agency for International Development. Sometimes it may be asked, maybe. So, according to USAID, the average amount of major nutrients are 36% protein, 52% carbohydrates, that is lactose, 1.3% calcium, and 1.8% potassium by weight. Then some these milk powders, they contain oxysterols. Oxysterols means oxidized cholesterol in high amount, because they are quite concentrated form of the milk. From 100 liters of milk, what they will derive, that means it is quite concentrated form of milk. So these oxysterols, They are suspected, they are not sure, they are suspected of being initiators of atherosclerotic plaques. That is, that in our arteries, blockage of our arteries. So they are suspected to be initiators of that. Then adulteration can also occur in powders. You must have listened that melanin adulteration in baby milk powder in China. So melamine, sorry. Melamine adulteration is basically, melamine is a nitrogenous substance. So when we check, we feel that protein content is very high because it is not able to uh, differentiate between the nitrogen obtained from protein or the nitrogen obtained from melamine. So melamine adulteration can occur in these powders. Then is, first thing which affect the quality of the milk powder is the bacterial quality of the original milk. For example, if we have a deep cooled milk, then psychotrophic gram negative bacteria, that is the pseudomonas species, they may grow. But these bacteria, they do not survive a very mild heat treatment. Then proteinases and lipases, which are formed by these gram negative rods, that is pseudomonas, they may survive and they will go into the powder. Then how we can prevent the growth? We can use good refrigeration properties, then refrigeration techniques. Then is we can limit the storage time, and then is the thermalization process. Thermalization process, if I say, in physics, what they say is that it is a process in which the bodies they reach thermal equilibrium through mutual interaction. Like two bodies are there, one is at cold temperature and one is at normal temperature. If they are kept in contact with each other, they will acquire the same temperature by that is by mutual interaction. Then heat resistant bacteria and bacterial spores, they are again of great importance because they can survive low pasteurization temperature, that is 72 degrees Celsius for 15 seconds. So because these powders are concentrated milk, they contain about 10 times as many bacteria per gram as the milk immediately after preheating. So we can give them a intense heat treatment, but then it will be a high heat milk powder which will be having very low solubility property. Then this is the contraindication, this is the problem. Okay, if we give them intense heat treatment, they will lose their solubility property. If we give them low heat treatment, then this problem may be there. It may be there depending upon the practices which are being used for milk production. Then is spore forming bacteria like Bacillus cereus and Clostridium perfringens. They are again very important to the powder quality. And then again, one thing, clean milk practices, CMP. All these bacteria are likely to originate mainly from contamination during milking, dung, soil, and dust. That is again what I say, clean milking practices. So basically, to kill these bacterial spores, they require higher heat treatment, that is 90 to 110 degrees Celsius, that is 10 to 20 seconds. It will not fulfill our aim. So UHT treatment is required, that is around above 131 degrees Celsius for very few seconds or fractions of seconds. Then is the neutralization of acidity. Whatever the milk is there, it is having its natural acidity. That is because of, this is again important point, it is because of milk proteins, citrates and phosphates that is present in the milk. So if we want to neutralize high acid product, then we have to use food grade alkalis, And the alkalis which may be used are sodium bicarbonate or sodium hydroxide, depending upon the kind of product we want. And again, one thing, temperature which is used for neutralization, it should be 35 degrees Celsius or less. And at least 15-minute time should be given for the reaction to occur before heating that milk. That is essential. Then, how this milk powder is produced. So there are different types of drying treatments which can be given to milk. For example, drum drying is there, spray drying is there, and freeze drying, vacuum drying, foam drying, fluidized bed drying. So there are different types of drying techniques which can be used, which we are going to discuss one by one. First one is drum or roller or film drying. Basically, what happens, it may be like single drum or it may be double drum drying. So, there are, suppose double drum, there are two drums. There is a very little distance between these two drums, and they roll in opposite direction. They move in opposite direction as it is visible in this. One is moving like this, and another one is moving like this. Now, from above, milk is poured, so it will form a thin mm, uh, layer on these drums, and these are heated internally. So when these go like this, so what happened, there is one scraping knife here. So whatever the milk that is dried, it will be scraped off and it will fall down. So that ways it can be done. If it is a single drum, then you can see there, on the downside of it, there is a big kettle. In that, the milk is filled, and the drum, it goes through this kettle, and the milk will form a very thin layer on the drum. And because it is internally heated, the moisture will evaporate because surface area is more. So that ways, and then a knife is present, it will scrap the dried milk from there. That blade is there. So this doctor blade, basically, it is set at an angle of 15 to 30 degree with the drum surface. So uh, when the milk is dried after complete rotation, then it will scrap off the product from it, and then the product is taken to the hammer mill, which will decrease its size. Size reduction will take place, and thereafter the sizing of the particles will be done by sieves, and then it will be packaged and stored and marketed. So this is how the drum drying is carried out. So these are all drum dryers. These drum dryers plus vacuum, because you can see a huge uh, thing here, like jacketed huge thing is there. So in inside of it, vacuum is maintained. So it again decreases the time of drying. Then comes the freeze drying. Freeze drying is also known by the name lyophilization or cryodesiccation. So basically, it is a process in which water is removed from a material, and it is removed from materials like heat labile material, which cannot whose quality deteriorates at higher temperatures. So for that, they we can use freeze drying, like for drying of proteins, because proteins get denaturated at a temperature more than 60 degrees Celsius. So we can go for freeze drying in that process. So what is done, whatever the food material is there, like milk is there, it is placed in a vacuum chamber. And first, no, before placing it in a vacuum chamber, it is freeze dried. It is kept at a temperature of minus 50 or minus 70 degrees Celsius. So it is completely frozen. Otherwise, what will happen? Foaming will happen during the process of lyophilization. So that ways it is completely frozen, so that all the water is in frozen state, and then it is kept in a vacuum chamber, and air pressure is lowered, and then heat is applied. So what will happen, when the temperature is low, pressure is low, and when heat is applied, then the ice, it will directly be converted into vapor state rather than being converted into liquid in between. So that water, it is removed, and what we get is basically the dried material. So this method is usually employed where we want to preserve the nutrient quality, where we want to preserve the amount of the nutrients. So that ways, it as compared to drum drying, freeze drying is more advantageous in terms of nutrients, but it is more expensive as compared to drum drying. So this is the process. First, the freezing is done. After freezing under low pressure, if ice is heated, ice evaporates as it is. And when water is added to a dry product, it is restored to its original condition. So here I have written, if water is heated under the vacuum system while being maintained at a temperature below that of its crystallization point, ice evaporates as it is. And that is the reason why it is kept at minus 50 or minus 70 degrees Celsius, because the temperature is maintained below the crystallization point of water, and then whatever the ice will be there, it will evaporate as it is. Otherwise, foaming will be there and the liquid may come out, and it may cause blockage in the lyophilizer. These are the kinds of freeze dryers. So that ways freezing can be, that lyophilization can be done. See, this is batch freeze dryer. This is continuous freeze dryer. There are certain zones in this figure. So here the freezing will take place in stages. The tunnel freeze dryer. Then comes the vacuum drying. So vacuum drying, one of the method of vacuum drying is that we introduce the nitrogen gas into the milk, and then the product is cooled to 1.7 degrees Celsius in a scrap surface heat exchanger, and then they are placed on a horizontal belt. So it first goes through a heating drum and then to a cooling drum. So basically, vacuum is maintained like 50 millimeter of mercury column, and then the scraper blades are there. They remove the product from the belt. So this is how vacuum drying is carried out. Then comes the foam drying. Foam drying is, first the air is mixed with the product, and after that, the product, it acquires a porous structure, and this porous product, it is placed on the drying trays, and then they are passed through, uh, air jets are passed through it. They moves upwards and downwards in the chamber, and air temperature is maintained around 105 degrees Celsius, and that ways the water is removed from it, and we can get the dried product. Then most important, and milk powder is generally produced by this method, spray drying, or either by drum drying in most of the cases. Now how this spray drying is carried out? Basically, spray drying means spray. Spray means whatever the material is there, it is converted into very small particle size. Very, very fine particle size it is converted. And by converting it into very fine particles, that means we are increasing its surface area. Side by side, these very fine particles, these are mixed with hot air. So when they come in contact with hot air, they immediately lose their moisture and they become dried. So this is the funda which is behind this spray drying. Now what happens? This is done inside a large drying chamber. This is the drying chamber. So here it is done, and the temperature of air which is entering into this spray dryer, it is kept around 200 or 220 degrees Celsius. And this atomization of the milk, it is done by these atomizers, or there may be like pressure nozzles or centrifugal spinning discs, and or we may mix it with compressed air so that they get atomized, the milk get atomized. So these they come in contact with the air, they lose their moisture, and then these are cooled, and thereafter they can be removed, and there we get the milk powder. So how it is done, so that is there. So if you see, here is the feed means milk is there. It is carried to the spray dryer with the help of a pump. There it enters. Here present is atomizer. This is atomizer. And from here, which you can see, there the air is there, which is heated. So here it enters, it will enter here, and here the milk will enter. They both will come in contact with each other. They loses moisture and they fall down. From here, they are carried to a cyclone. From there, the milk particles are collected and the air is further sent back to the heating section where it will be again heated. So this is how spray drying is carried out. Now, why? What are the objectives? It is to remove the moisture, it is to reduce the cost of transportation, to improve storage of the product, and to provide a product fit for many food manufacturing operations. Now, what are the processes involved? First one is the heating of the air. देखिए, if we want to heat the air by using steam, then we can increase the temperature up to 175 degrees Celsius, and that is again very hard to reach. So and we require air which is heated to a temperature of 200 or 220 degrees Celsius. So now what we can do, basically we may use hot gas by burning natural gas, that is methane. Another possibility is the hot air. We can do direct electric heating of the air, direct burning of the natural gas in the drying air, but it causes contamination with nitrogen oxide, so that is not preferred. So that ways, by using these methods, the air is heated to around 220 degree Celsius. And after drying, the temperature of air comes down to 100 degree Celsius. This is how it is done. Here you can see there are in the spray dryer, there are three nozzle kind of structures. So these are atomizers. And from here, the hot air will enter. Because they are converted into very fine droplets, surface area is increased to a very large extent. So this hot air, it will immediately dry them. They will be converted into milk powder. From here, they will come to a fluidized bed dryer. There again heating will take place. Here the moisture content will be around 4 to 6%, and here the moisture content will be further reduced to less than 4%. You can see here perforated belts are there. So from downwards, again the hot air is passed through this bed. That is why it is known as fluidized bed dryer, because hot air, it will come from the perforated belts, and then they will further dry the powder particles more to moisture content less than 4%. Then is the atomization of the concentrate, atomization of the milk. So basically, atomization is like this. This is atomization. You may see that milk is coming from very minute pipes, and then they are converted into very fine droplets. This is the process of atomization, that is to increase the surface area of the milk. This is this is atomization of concentrated milk. This is spray dryer nozzle. So you see how the stream of milk is converted into very fine particles. Now, atomization aim is to reduce the milk to a particle size so small that due to tremendously increased surface area, the resulting mist of milk projected into the current of heated air, it surrenders its moisture near instantly. As soon as it comes in contact with the heated air, it will lose its moisture content and it will fall down. Now see, it is an interesting fact, and you see this. It is estimated that zero point 0.5 liter of milk so atomized contains these many particles. That is 56254311140 particles. And that is an area of 24,586 meters square. So now you can imagine what kind of fine droplets are being created by the atomizers. And here, one thing more, average particle size of the milk fog, which is provided by atomization, it should have a diameter of around 50 micrometers. So this is how it is done. The milk, it should be sprayed into the hot air in the form of very small particles, as nearly uniform in size as possible. Because what will happen, if there is non-uniform size of the particles, then smaller particles, they will dry fast, and bigger particles, they will take time. So, the point up to which the bigger particles are dried, the small particles, they will burn and they will lead to cooked flavor. So that is why uniformity in the size is very important. That is very important in this case. Now, advantages of atomization: rapid evaporation, less effect on the quality of the product because they will be in contact with high temperature for fractions of second, and they will be immediately dried. And atomization is also known by the names fragmentation, spraying, pulverization, division, annihilation, obliteration. So these are the various terms which are used for atomization. Then there are different types of atomizers. Because you are engineering students, so I have tried to incorporate, because I am not an engineer, so if there is some shortcoming, please bear with it. So these are different types of atomizers. They may be pressure jet type, pneumatic type, centrifugal type, and centrifugal are further of three types: hanging bowl, disc type, or ring jet type. So in case of hydraulic pressure jet type, basically it forces the milk at a very high pressure, that is 141 to 211 kg per centimeter square, and it is through a very small orifice. It is only 0.125 millimeter in diameter, and it is made up of hard steel disc, because at such a pressure otherwise it may also blast. So basically this atomizer, it produces a hollow cone spray where the droplets are arranged in a ring, like this ring, and from inside it is hollow. So the particles which are very small, they will be on the periphery, and the bigger particles will be towards the inner side. Then are the pneumatic type. Pneumatic type, in this stream of compressed air is used. Basically, the air, it collides uh, with the fine particles of the liquid at right angles to it. So in this case, no high pressure pumping of the milk is required. Moreover, because less pressure is there, so that ways the orifice erosion is also reduced. And moreover, concentrated liquid can also be sprayed in terms of increasing the energy efficiency. Then is the centrifugal. Centrifugal, there no pressure is applied, but the velocity is increased by a rotating device. And the milk, it leaves the periphery of the atomizer in the form of either thin filaments, which break up into small uh, circular droplets in an umbrella shaped spray. So basically, they leave the disk at a very high speed, that is 100 meter per second, like this. They will come out from these round outlets, and they will project out from it at a speed of 100 meter per second. This is centrifugal type. Now is the mixing hot air and atomized liquid. So this is the mixing of hot air and the atomized liquid. Basically, they enter into the chamber and they are mixed with each other. And as soon as they mix with each other, the air enters at a temperature of 220, and it immediately cools down to a temperature of 100 degrees Celsius because of the exchange of the heat. So basically, air, it enters at right angles or tangential to the movement of the milk particles. This is how it is done, mixing of milk and air. Like in this case, you can see air is coming from the central piece, and milk is inclined, and it will mix with the hot air. And in this case, milk is in the center and air, it is coming from the sideways. So this is how these practices, this is usually practiced. Then is the separation of the powder and consumption of the dried air. So basically, it is done with cyclones. So the air, it is strongly rotated, and basically the lower conical part. This is the lower conical part. It helps in the formation of a cyclone, and most of the powder, it is discharged below, and then this powder is cooled, and then it is packed. So the very small powder particle size, these are known as fines, and these are collected and they are again made to enter into the spray dryer for atomization, so that their particle size may increase, so that it does not hamper the solubility of the milk powder. So when the utilized air, then it is passed through the cloth filters, and thereafter wet washing may also be carried out, and then it is again recirculated and made to enter into the spray dryer. Then is the aggregation of the powder particles. As I told you initially that for making instant milk powder, we require certain additional process, and one process is agglomeration, or sometimes that is agglomeration for instantization. So here aggregation is basically to increase the particle size, so that the we can attain a required particle size and it can be solubilized easily. For that purpose, aggregation of powder particles is done. This is aggregation of powdered particles. As you can see, many fine powder particles, they combine with each other and they form a particle of required size. So this again shows fluidized bed dryer. I told you, from beneath, the hot air enters through the perforated beds, which allow the secondary drying of the milk powder particles, which are obtained from the spray dryer. Then these are the characteristics of spray dryers, like continuous operation, little labor, and they may handle different products also. Thermal efficiency is low. Operations depend on large surface area of the product. Separation of air and product after drying is important. Unit is easy to clean. Economy of moisture removal is improved, and product properties and quality may be effectively controlled. This is a spray drying process. Now comes skim milk powder production. So there is a difference between whole milk powder and skim milk powder. Now, what is the difference? In case of skim milk, no fat is there. In case of whole milk, fat is there. So whole milk is more prone to rancidity as compared to the skim milk powder, because in case of skim milk powder, the fat should be less than 1.5% on dry weight basis. Now, how it is produced? Skim milk, it is preheated to a temperature of 85 degrees Celsius for 20 minutes when the powder is intended for bakery trade. That is to be used in bakery products. Low temperature required for manufacture of low heat skimmed milk powder. Now, what happens? Now, how it is done? Basically, what is done is, whatever the milk is there, first it is heated to a temperature of around 70 to 73 degrees Celsius. Then the spray drying is done. Spray drying will be carried out at 220 degrees Celsius, because it will be mixed with air at a temperature of 220. Outlet of the air will be around 90 or 100 degrees Celsius. Then whatever the powder is there, it will be first fluidized bed drying, then it will be moved to a cyclone, and thereafter the air, it will pass through the cloth filters, and whatever the powdered is there, it is cooled to 30 degrees Celsius, so that there is no browning of the powder. So that is why it is cooled to around 30 degree Celsius. So this is how it is done. First reception, then cooling, then preheating, then separation of that is cream separation, then pasteurization. After pasteurization, then again heating it to 85 degrees Celsius so as to remove certain amount of moisture before it is entered into the spray dryer. And then again reheating, then filtration, spray drying, cooling, sifting, packaging, storage. Then is the whole milk powder. Basically, whole milk powder, in this the fat content of the milk is kept around 3.2 to 3.5%, because it will result in the standard fat content at dry weight basis, that is not less than 26%. First thing, the milk will be clarified. Thereafter it is homogenized, and after homogenization, first stage, it will be carried out at 2500 psi at a temperature of around 63-64 degrees Celsius to inactivate the lipase enzyme, because homogenization, surface area of fats will increase, so lipase can attack on them and cause the breakage of the fats. So to avoid that, it is heated to a temperature of 64-65 degrees Celsius, so that the lipase enzyme gets deactivated, and thereafter second homogenization is carried out at a pressure of 500 psi. So thereafter, it is given a high heat treatment, that is 80 to 93 degrees Celsius for 15 to 30 minutes, so that the sulfhydryl compounds are formed, and these sulfhydryl compounds have reducing properties and they have antioxidation properties. Then it will also lead to concentration, and then spray dried, and then again cooling to 30 degree Celsius. So this is how it is carried out. Then the last thing is instantization. As I told you, agglomeration, instantization, that is to produce the instant powder. So basically, it was this discovery was made by Mr. Peebles in 1954. This is how it is done. First is spraying, then is bonding, then drying, and then is agglomeration. So after agglomeration, what we get is, it is the instant milk powder. So agglomeration means clustering. So basically, in this method, what happens is that there is transition in state of lactose from glass state to microcrystalline state, which modifies its properties to make it more wettable and less hygroscopic. That means it is not going to absorb moisture from outside, but it will be having more wetting properties and more solubility. So instantization is basically uh, what happens, the surface of the milk powder particles are humidified, and these particles are partially dried during manufacturing so that their surface is sticky, partial crystallization of the lactose, and which leads to the formation of microcrystals before the particles are re-dried. So this helps in agglomeration or the granulation of the particles, because they are having a spongy structure, and water can very easily penetrate through this spongy structure, and this will allow the particles to disperse properly and sink, so that they have very good wettability properties. So this is instantization. As soon as we put it into a glass of water, they will be immediately dispersed and sink to the bottom. They will not float at the surface because of their spongy structure, and water will immediately penetrate through that spongy structure. So this instantizing, it is basically because if the particles are having very small size, they will not dissolve, they will only be partially dissolved. So in agglomeration, these particles collide with each other so that their size is greater than 125 micrometers. So this is how they look in a glass of water. So they will be having good dispersion and good wettability properties. So by two ways agglomeration can be done, that is spontaneous and forced. This is the thing. And here I have given a table. Like spontaneous, it is unprovoked collision of primary spray particles. And then forced primary, this is intended collision between primary spray particles from different atomization devices. Spontaneous is random, unprovoked collision of primary spray particles and fines by Venturi effect. And forced secondary, intended controllable collision between primary spray particles and fines. That means the milk powder particles which are very, very small in size after returning them to the atomization zone. This is Venturi effect. Initial, then they are allowed to pass through a very small orifice and immediately they are expanded. So what happens? Initial velocity, when they will enter into a narrow space, viscosity increases and again the viscosity decreases. So that ways the milk powder particles and the fine particles, they will collide with each other and they will form what? Aggregates. Then is the packaging of skim milk powder. Packaging is basically they should have good oxygen barrier properties. They should have good moisture barrier properties. They should have good tensile strength, and they should be very easy to fill, seal, handle, and they should be easy to empty also, and reasonably priced. So what we are using is a product is packed in cartons, polythene bags, or plastic bottles. And generally, we use outside a craft bag, and it should be like 3 to 3.5 stitches per inch, so that it is moisture. It does not allow moisture to enter into the packet. then is the whole milk powder. Here the problem is there because it is quite susceptible to oxidative damage and flavor deterioration because fat is present into it. So for that, whatever the oxygen is there, it is removed, and thereafter some inert gas is added to it. So the amount of oxygen that is present in the headspace of the container, it should be less than 2%. So basically what is done, air is removed in a vacuum chamber, and thereafter we release nitrogen, that is the inert gas, and then seal it. So that ways it will be having, uh, we can stop the oxidative deterioration of the whole milk powder. So this is the thought of today. Do not dwell in the past and do not dream of the future. Concentrate the mind on the present moment. So I request you all, please go through the lecture and try to solve the MCQs from the book which I have messaged in the group, and questions from your side. So no questions. Good night to all of you. All the best. Thank you.